Hey folks, Luke Skywalker here, and this is more on graphing greatest integer functions. In fact, this is number 18 out of your notes, or out of your lesson from yesterday, or from the prior lesson. But first, let's do board problem 6. Write an equation in standard form, ax plus by plus c equals 0, that passes through 3, 1, and is perpendicular to the line that goes through these 2 points. Okay, first got to find the slope. The slope of this line right here is 3, so perpendicular slope is negative 1/3. So I'll put it in point slope form. Y minus y sub 1 equals negative 1/3 times x minus x sub 1. Remember, this is going through this point, this x1, y1. Okay, I multiply both sides by negative 3, and I finally get to that equation right there. Okay, all right, here's number 18. It's a struggle. I know greatest integer function is a struggle, you guys. In fact, I struggled a little bit when I first saw this, boy, many years ago. But it was a struggle for me too. So it's just the greatest integer less than or equal to x. So this is going to be the greatest integer less than or equal to. So what I'm going to do is going to set it equal to some integers, you guys. Set this inside piece. Since they're integers, this equals integers, I'm going to just set this inside thing equal to a bunch of integers. So I let it equal negative 3, negative 2, negative 1, 0, 1, 2, and 3. This inside stuff. And then what I'm going to do is divide and solve for x. I'm going to divide by negative 3, divide by negative 3 on all of those. I'm going to divide by negative 3. And so this is my f of x, negative 3, negative 2, negative 1. You can't see that very well. 0, 1, 2, 3. Those are my f of x, or my y's. And it gets that when x equals these values right here. So I'm going to set up a table right here, you guys, and always work from the smallest x to the largest. This is the largest x here. This is the smallest x. So I'm going to use the interval x equals negative 1 to negative 2/3, and f of x equals this 3 right here. All right, so from negative 1 to negative 2/3, f of x gave me 3. And then it jumped to 2. F of x jumped to 2 from x equaling negative 2/3 to negative 1/3. Then it jumped it to 1 at 1/3 to the other one. So when x equals negative 2/3 to negative 1/3, f of x equals 2. And then when x equals negative 1/3 to 0, it jumped to 1. F of x jumped to 1, and so on. So what's happening is it's giving me these graphs right here. Okay, so from x equals negative 1 to negative 2/3, notice my x-axis is separated by 1/3, you guys. This is negative 1/3, negative 2/3, negative 1. This is positive 1/3, positive 2/3, positive 1. So let's go from x equals negative 1 to negative 2/3. That's this little region right here. F of x equals 3. So it's going to be way up here. It's going to be closed at negative 1, open at 2/3. And then it's going to go to 2 right here from negative 2/3 to negative 1/3. So closed at negative 2/3, open at negative 1/3. And then it's going to jump and go down to 1 from negative 1/3 to 0, closed, open. Then it's going to jump to 0 from 0 to 1/3, closed, open, and so on. So there would be that graph right there. All right, hope that helped a little bit, you guys, and then I'm just going to have you guys do a review assignment, and it would be that.